Let's take it into punch design. So this is where quick strip kind of stops. Quick strip so far is what you've seen is a subset of quick press. Quick press now extends it to go to the next level, which is punch design and die set creation and drawing creation. So we're going to do that by setting up a project ID and giving it the press information, maybe the style of die set, maybe it's the customer specific one, and I'm going to give it a project name, T01, and it's going to be the first project for that project name. And then we can pick from different die set styles. These can be defined by you. So what you see here is just a series of samples. And that's really where the power comes in, is you can define these yourself very easily, and then they can be reused. Now let's go to the next one. The next thing it's going to say is, alright, so you got this new job, you want me to use this style of press or this style of tool set. And now what about your clearances for this job? Anything specific? You can change it depending on the style of the tool, the taper, the land. It's all going to be created for you. So you can automatically change anything we create, but it's going to give you a 90-10 approach. 90% of it's going to be done. Now, it built us an assembly. So we already got ourselves an assembly. You don't see any parts yet because we're going to build punches first. But we do have this upper component, lower component, middle component. You'll notice that as we build our punches, whether they're cutting, forming, bending, whatever, we'll auto-organize your die for you. Let's get started with tailoring some of the cutting punches. I'm going to pick this cutting punch right here, and I'm going to go into setup of the punch itself. I could tell it to be any type of retaining method, and these are customizable. I can tell it to use the system template, which is whatever I want as the default. As you can see here, we have many different styles, and there's no limitation on the amount of styles you can have because these can be defined by you. So you can have everything from a manufactured, like a ball lock punch. You may want to do some other type of configuration where you have a fastener through the bottom, step with shoulder, pedestal with multiple fasteners, dowel pins, and so on. The main idea here is you can tailor it. Also, the openings that go below the die steel, you may want them to all be direct offsets. You may not. You may want them to be all rectangular. You know, these are all variations of this. Now, let's batch process the whole thing. Yeah, the whole thing. Let's take it and create all the cutting punches real time. So what this will first look for is it will look for similar punches. Okay, so let's say you have a similar piercing diameter, which is a purchase punch. It's going to bring in, and it's going to first of all look for that in the catalog. If you can find a straight shank, it will. If it can't, it will create a stepped. Now, it will create all the holes through the entire die set based upon the current job information. It will also create any drawings necessary for each punch. But that thing about checking if it's unique or not, it doesn't only work for purchase punches, it also works for totally custom punches. So you can see there's different shapes on here. Let's say it was some kind of U shape that was used 5 different areas. The punch will only be created once, one ID, okay, one part number, but it will be instanced the 5 times. We figure that out. Other CAD systems are going to create you 5 different part numbers even though it's the same punch. Talking about confusing people downstream. The next thing it's going to do, of course, it's going to, like I said, build all the holes. Then it goes into the die or into the punch assembly, and it figures out what assembly do I belong to. Do I belong to the upper components, like the upper die set? And it could be the lower die set or the middle die set. It rearranges itself. If it's a sub-assembly, it decomposes itself and then rearranges itself. Like in a case of a bending die, right? There might be a punch on top and there's going to be a bend on the bottom. We need to dissolve the sub-assembly into 2 different areas. We take care of all this for you. On top of that, we're going to bring it into the strip layout and we're going to mount it on the punch or on the strip area. You do not have to assemble this. We do it all, and we do it in high performance mode. Traditionally in 3D, you're going to mate everything. We don't mate anything. We programmatically control it with the strip itself, which keeps it very high performance. So there are a number of other things, and like I said, drawings are being created too. So you still rely on drawings, which most of us do. We're going to automatically have the drawings done. Yes, you might have to tweak them a little bit, but everything is automatically picked up. The naming convention, the project ID, all the notes in there, all the attributes about the punch can be transferred into the drawing. So a lot of that is all kind of being pushed aside. If you're doing that manually today, It's going to be difficult to compete. So finally, it's going through and finishing up. Now it's going to bring in that last thing that I did that was custom for that one punch. It's going to bring in that custom retaining option that I specified for that one punch. It's going to look for the longest non-cutting edge, and it's going to align itself to that edge. It's going to automatically know that it's on the bottom of the punch holder because that's the way that template is set up. Well, the punch holder can be at any level per job. Well, in this case, it knows the current level. That's the whole beauty of the automation. Then we can rearrange it. We don't have to take where it gave it to it. You know, you can tweak it. Everything that we create can be modified using traditional SolidWorks commands. This makes it very easy to modify if you're just getting started, for instance, and you don't know exactly how you want something created. So let us do the 90%, and then you can tweak and put your value-added design on top of it. So it's just finishing up here, and as you can see, it's also going up to the die face, and it's going to adjust. By the way, if there's any forming operation, then piercing or notching, we will automatically shift the penetration level. So you don't have to, and obviously that occurs often. So finally, let's just wrap up here. And I kind of like to do the whole thing just to show you that you could actually quote this out. If you spend a half an hour today putting together a presentation, you can quickly do that and still get your raw material properties, all your bounding boxes. And yes, we're working on a punch block notching capability, so you take all your piercings and notchings that are custom and throw them together in a cube and automatically nest them for your wiring operations. Yes, you'll be seeing that in the near future from Quick Press. So you won't have to sit there and build your own punch blocks. You just automatically throw all the punches in there, and it will automatically nest them with the material offset and so on. So these are the type of innovations we're listening, and we're taking our customers' input, and we're rocking the world. And we're only in version 2 right now. In version 3, you'll see many, many other enhancements. So you can see there that we've got ourselves our punch set up pretty quickly. And here's that keyway I just mentioned. What if I want that on the other side? Well, simply by clicking on that entity on the top edge and just say edit the key reference, it switches it for me. So I don't have to mess around. So very quickly you can make changes and you can make modifications. We can come back and add more punching, forming, bending, and all that real quick. Let's just keep moving here. Let's put an insert. I want to do another example of a PRL, because PRLs are very powerful and your imagination is the only limitation. I'm going to click on this item right here, and I'm going to click on this punch. Okay, I want to do a die plate insert. I can name it anything I want. And I want you to notice on the left here, it sized it at 55 by 14. Okay, let's make that 65 by, say, 25. Okay. The automatic adoption of this die insert will pick up on the current die plate thickness of the job. It will automatically find the center of that punch, and it will build it to my specification of 65 by 50 or 65 by 25. You'll also notice that is picked up on the thickness, which we haven't shown you the thickness wizard yet, but that's right here in the menus. And I purposely don't show it up front, because then if I knew everything up front, it's real easy to design, right? And then it wouldn't be design, it'd be called robots. And you can see here that we can tweak anything about the job we want. So you can tweak all variables of the die structure. Now let's go to the final portion, which is our die set, so we can finish here on time. Make sure we've got some time for questions, and then just click on here. And we're going to create ourselves the holes, and we'll do it on the fly. So we have an option. Do you want to create all the holes in the die set at once, like when I build the die set? Because there's a lot of other things going on here too. We have to size the die set. It has to pick up on any thickness variations, penetration depth, all the variables we've kind of set so far. Then it's got to look through and it says, hey, what punches are interfering with what components? And you don't want to just cut any component, right? You want to cut specific components. And we're doing it in an automatic mode, so it is actually intelligent enough to figure out what to cut and what not to cut. I think this is a very important point. So if you've done 3D, you know exactly what I'm talking about. You just can't go in a die set and start blowing through it. You know, there's a number of reasons for that. There might be a component in there that you need to move before you blow the hole through there, right? The other thing, of course, is we need to determine which type of plate is what, so we cut the right clearance. Also, you'll notice that this die set's coming in from a previous template that's smaller, and it's going to have to get bigger. So there's a lot of 2D things driving this, and you can tweak it before or after. So you don't have to know where you're going, and that's true design, is you have to get into it in order to tweak it. The whole idea is how much manual work are you getting to add value to the job. So here we're going through, each assembly is being created, so now we have a final upper, middle, and lower. And of course the components are being transferred into the proper subassemblies. Also, everything's being renamed, so you don't have to sit there and mess around with all the different combinations of naming conventions for the current job. Of course, standard components don't have to be renamed. They could be called from a standard location, or they could be if you prefer that. Finally, what it's going through now is it's doing the whole creation. You can see it's going through and it's checking, okay, I got a series of punches, they have to go through certain plates, and then of course we got that insert sitting on a punch, so that means that the insert needs an opening, and the punch itself has to go through the insert. And all these things have to be figured out. So we're doing it very, very quickly and much simpler than you doing it manually, because we won't forget about a hole or two. You might be able to do that. We want to take that off your mind, and we want to allow you to do true value work, not just redundant simple operations, but you have to be done. So finally, you can see it's going to be creating the holes, and you'll see kind of through the model. Right now it's in a transparent mode, so you got a kind of a glass model to work with. Also, we can modify anything now. We can go back to the part, change the part. If we want to just go to the strip and change the process, we can do that. If you want to change a punch or two, you can do that. And then on the bottom here, you'll see that we have a series of different assemblies. So I'm going to pick up the lower assembly, and you're going to see that we have a number of design issues going on here, but at least we can see them. Notice this lifter came right through the actual insert. The insert itself has the taper and land and its clearances, but the lifter is coming right through it. Why did it get cut? As I mentioned earlier, it's intelligent. Also, if I want to change the lifter position, guess what I do? Change a 2D sketch. Yep, majority of the stuff you see on the screen is driven from 2D. That's the way 3D works, but also a methodology. There are different approaches. What I'm going to do is edit the sketch. And not only is it an easy sketch to modify, it's a series of points. It doesn't get any easier. And I'm sure that if you've done 2D work, you'll agree. There's nothing easier than modifying the simple primitives of points. What I'm going to do is change the position of the point, and I'm going to add a point. Alright? So kind of just give you a flavor of how to make change in 3D is once the point tells it the position, of course the assumption is you need the same type of lifter but a new series of holes, and of course you got to move the original, make sure it doesn't disrupt where it was at. We need to heal all that up, and it's being done for us automatically. It's checking the interface. You can see that it's rebuilding it, making sure that it's cleaning itself up. And now you notice that we've got ourselves a new lifter and the original one moved. Here's the actual insert, and yeah, if we open up the part drawing, here's the insert of that drawing, or the drawing of the insert, that is. Now, this is a very basic drawing, but you get the idea. It's been renamed to the current project. You can do anything you want. All the detailing and all the capabilities of SolidWorks are very powerful. I don't spend a lot of time on it because it's called core SolidWorks at this point. Bills of materials are automatic, hole tables are automatic, auto ballooning, sectioning, details. There's probably 8 different ways to section, 3 different ways to do ballooning, and so on. So that's something you can learn more about through a local reseller in your area. If you don't know of one, we can hook you up with one. There's about 250 in the U.S. and Canada alone. So let's close this up and let's finalize this discussion. We're just a couple minutes over, and I apologize for that. But I do want to show you that this is also very powerful from a communication standpoint. 2 more things. One is that can you animate the die and put it into motion to understand the visual and the timing properties. And yes, we're always trying to make it better to do it in a virtual environment before you start cutting steel. So if you can visualize the movement of the die and you can see where the camming operations are occurring, where is interference occurring, isn't that going to save you time and money and rework and frustration? Well, it's certainly going to blow your customers' socks off, because while your competition is giving them 2D approximate strip layouts, you're giving them an e-drawing of this entire die set, and you are empowering them to cut the part. You can do anything you want, and you've got all your raw materials calculated. And what you can do right here is click on that e-drawing button, and it will automatically create. And this file is less than half a meg. You can't even touch that in 2D. And you can see here that I have the 3D model, and this entire thing is free to your customer. Now, if I want to move a component, I just grab the move little hand, and I click over here and move that component. If I want to explode the assembly, I click on explode. If I want to put an animation in here, I can. How about sectioning? If I want to section it, or the client wants to see, or maybe the shop floor, after you get the job, you want to give them a better tool to understand how you designed it. And then finally, on the left here, you'll notice that you have the full tree. So you have all the part numbers, and you have all the manufacturer information in here. So the whole idea of communication now has been really enhanced by you utilizing 3D technology, cutting down on errors, time to market, and ultimately just less hassle work, less manual type work, so you can focus on true value-added design. So at this point, that pretty much concludes my introduction presentation. And I do stress that was an introduction because there's so much more to our application, but I can only do so much in about 30 minutes. So is there any questions or feedback at this point? Or if you'd like to reserve it, that's fine too. We can call you and talk with you privately. So any questions? Well, once again, we really appreciate your opportunity, the opportunity we had to present to you today. We know it's difficult to break away even for a short period of time like this, and hopefully we can help you out and get some feedback. If you don't think it's a good fit right now, give us some feedback, and you'll be seeing probably something returned to you very quickly. Version 3, for instance, is coming out at the end of this quarter. So you'll see 150 major enhancements. We'll be at Metal Forming, Booth 424 in Nashville this year. And, of course, we're always available via a web presentation if you'd like to learn more. So thanks once again, folks. Have a great day. Thank you. Bye-bye. Bye-bye.